Hello, welcome everyone. We're excited to have you here all today. Thank you for attending today's seminar focused on GIS for bike lane safety and efficiency. Ecopia is thrilled to be collaborating with ConnectMii and today's participants and sponsors to continue to support the GIS for state and local government asset management series. My name is Bill Singleton, part of the senior leadership team here at Ecopia AI, and I'll be your host for today's session. My goal at our organization is to support communities and civil engineers in their objectives to make communities safer, more accessible, and equitable for all modes of transportation, including communities currently at all different stages of their journey to be a more cyclist-friendly community. Before we get started with today's introduction, we're going to open up a short poll to learn a little bit more about everyone in today's audience. All of our participants today are working in several aspects of the data collection, educational, and implementation ecosystem to support bicycle and other multimodal transportation objectives. Ecopia AI, along with our supporting presenters, have supported hundreds of communities and state governments across the U.S. in their efforts to improve access to transportation infrastructure. We look forward to all of your questions toward the end of today's session. So why is this topic so important? Because there's never been such an opportunity and support to help improve bicycle and pedestrian infrastructure across the country. The United States has a range of federal funding opportunities aimed at enhancing bike safety and promoting active transportation. The U.S. Department of Transportation, through various programs, provides grants and resources to support the development of pedestrian and bicycle infrastructure. One notable initiative is the Active Transportation Infrastructure Investment Program, ATIP, which is part of the government's Investing in America agenda and is bolstered by the bipartisan infrastructure law. This program focuses on creating networks of connected bicycle and pedestrian paths, improving access to public transit, and ensuring safe travel for non-motorized transportation modes. With a substantial budget, the ATIP aims to address barriers to safe, accessible, and equitable pedestrian and bicycle networks, particularly in disadvantaged communities and areas with a high reliance on public transportation. Additionally, initiatives like the Reconnecting Communities and Neighborhoods program provide essential funding for bike infrastructure projects, complementing other federal programs such as Safe Streets and Roads for All, or the SS4A, Rebuilding America Infrastructure with Sustainability and Equity, or the RAISE program, recreational trails, highway safety improvement, and surface transportation block grant programs. These initiatives collectively contribute to the creation of safer biking environments and the promotion of active transportation as a sustainable and healthy mode of travel. For local governments, regional planning organizations, and state departments of transportation, these funding opportunities are crucial in planning, designing, and constructing active transportation networks. Such networks include sidewalks, bikeways, and trails that connect key destinations within communities, such as schools, workplaces, residences, businesses, recreational areas, and medical facilities. Moreover, they support the construction of trails and other routes that serve as backbones for connecting multiple communities, metropolitan regions, and even states. The emphasis on active transportation reflects a growing recognition of its benefits, including positive health impacts, reduced traffic congestion, and lower greenhouse gas emissions. By investing in bike safety and infrastructure, the federal government is not only enhancing the quality of life for its citizens, but also contributing to broader goals of sustainable urban development and transportation decarbonization. These efforts align with the U.S. National Blueprint for Transportation Decarbonization, which advocates for the establishment of safe, active transportation networks enabling fewer and shorter car trips. Organizations interested in applying for these grants can find eligibility requirements and application details on the official website of their respective programs. However, within this webinar, we have also provided resources through the resources links to help guide and explain how to get through to some of these resources. It's important for applicants to carefully review these requirements and prepare comprehensive proposals that demonstrate the potential impact and sustainability of their proposed projects. The competitive nature of these grants means that successful applications will likely be those that clearly articulate the benefits of their projects in terms of safety, connectivity, and community enhancement. And that's where highly precise GIS data that we will discuss today comes into play. To quickly summarize, this is a very exciting time. The U.S. federal government funding opportunities for bike safety are part of a concerted effort to improve the nation's transportation infrastructure. By providing financial support for the development of safe and connected active transportation networks, these programs play a pivotal role in promoting healthier, more sustainable, and more equitable communities across the country. I want to do a quick recap of today's presenters and the topics that we will address. We'll start today by learning from Kevin O'Brien, Virginia organizer of the Washington Area Bicyclist Association, who will highlight the hidden and typically overlooked and sometimes dangerous challenges that users of DC's fastest growing active transportation network typically must navigate, and how we can integrate users' perspectives into our GIS models and design. We will then have Craig McCabe, Senior Principal GIS Engineer at Esri, to discuss methods to analyze the access to bike lanes across the Washington, D.C. area. We will then go to Samantha Kriegsman, Senior Partner AM at Samsara, who will discuss the real-time GPS tracking, AI dash cams, safety coaching built to revolutionize bike safety and efficiency, specifically with case studies highlighting their work across Denver and Athens, Clarke County. I will then wrap up today's presentation portion discussing new methods to collect large-scale, precise bicycle and active transportation asset information across the U.S. using the latest in machine learning technology, and how this is being used by MPOs and civil engineers alike for long-term planning and federal funding applications. We will conclude today's presentation with a short Q&A forum, and we're looking forward to all of your questions. Before I hand it off to Kevin, let's take a quick look at the poll results. So as we can see today that we have a very large portion of local government. I'm excited to have the opportunity to share our experiences working at the municipal level amongst all of our presenters today. It looks like we're heavily geared to the United States. And so looking forward to showing you the data collection methods and the new solutions that are available in the marketplace. And it's also, as I mentioned in the introduction, a very exciting time with all of the federal grant opportunities that are available to individuals across the U.S. And it seems like we have a pretty even split. Looking forward to addressing both public works and transportation, but also how this can affect land use and planning for a number of these areas. And it looks like we're also pretty spread out equally over the size of cities, which I mean, there's always challenges at every different level. So looking forward to address all those pieces. Well, without any further ado, I want to hand it over to Kevin, and looking forward to answering your questions later today.
All right. Let me get my screen shared here. Good morning or afternoon, depending on where you're at. I'm on the East Coast, so afternoon. And thanks for being here today. And thank you for the introduction and for the folks who've made this possible today. My name is Kevin O'Brien, and I will be kicking things off today, talking a little bit about what it's like out here in our bike lanes and on our trails in the nation's capital. So who am I? Again, my name is Kevin, and I am an organizer and a professional advocate with the Washington Area Bicyclist Association, or WABA. We've been around for more than 50 years, teaching folks how to ride, advocating for more and better policies and bike facilities, and generally supporting the cycling community here in Washington, D.C. I don't have a planning or a tech background, but I was invited here to share my perspective as an end user of our bicycling infrastructure, and to share some of the challenges that some of which may be a little bit less obvious that we face. So I really am here just as a bicyclist. So let's jump right in. In general, things are moving in the right direction in Washington, D.C. We've made a lot of investments over the past 2 decades in terms of bike infrastructure, and we have one of the most robust bike share systems in the country. Pictured here on the left is the downtown area with the Capitol bike share stations noted by the red dots and green lines showing the bike facilities. On the right, we have a little bit of a fuller view of our bike network as it's coming into realization. In orange, you see the projects that are to be completed this year. In blue, projects slated to be completed next year. So a ton happening. And these investments are really paying off in terms of our bikeability rankings. Here's just a snapshot of the latest report from Capitol Bike Share, showing just the tremendous year-over-year and month-over-month growth that we're seeing. Every month it's breaking new records. But of course, it's not all sunshine and rainbows out here, right? Despite the investments made in the network, we, like much of the country, have seen an increase in traffic fatalities. And bike commuting percentages remain stubbornly in the single digits. Some of that can be attributed to surveying quirks that don't always do a good job of counting bike commutes and post-pandemic changes to travel patterns. But the fact remains, not as many people regularly ride a bike as could reasonably be expected to, or have expressed interest in riding. You've all seen likely some version of these numbers. And I think the question is, what's stopping these folks, right? These folks who are interested but concerned. What are the challenges and barriers? Research on this is pretty clear. The single greatest barrier to bicycling are the 1,000-pound metal machines that we have to share the road with. But other factors contribute, some of which, like the weather, are a little bit out of our control. But what we can focus on, are two of the factors that are somewhat in our control: connectivity and the perception of safety. And so that's what I'm going to talk a little bit about here. These two. Many folks don't ride simply because there isn't an easy route to get where they want to go. In DC, east-west travel is a noted challenge that advocates are hoping to address with facilities on Q&R Street, as you can see on the right. And then on the picture on the left, and then the picture on the right, we can clearly see where there's a gap on Connecticut and Florida avenues. And you'll hear from some of the other speakers about ways that we can, intelligently identify some of these gaps. Of course, some gaps in the network are a little bit more pernicious, are long-standing and rooted in past racially motivated urban renewal efforts. We see a map here on the right showing predominantly Black Ward 8 with I-295 cutting across diagonally and separating residents from the Anacostia River waterfront in its vast trail network. Flipping to the satellite view, we can really start to see the scale of the barriers. And then if we zoom in even more into that street view, we can see this terrifying little sidewalk, about 4 feet wide, underneath all of this infrastructure. Past policy and infrastructure decisions like I-295 limit mobility to this day, and the fixes are pretty challenging. Then we have gaps like this, more of a navigation gap, where overlapping facilities that show up on Google Maps nicely don't quite mean intersecting facilities. Here's what this looks like on the street. Not an issue for planners, but kind of a pain for the unsuspecting rider realizing that he or she can't easily move between these two green lines that are crossed on the map. Then there's the safety challenges. Even when bike lanes do go where we want them to go, they are all too frequently blocked by vehicles or equipment, forcing cyclists to stop or merge into the vehicle travel lane, irking experienced riders, and frightening away would-be riders. And I'll just say it, government vehicles are sometimes the worst and most frequent parking offenders. Of course, it's not just vehicles. Bike lanes being frequently, on the edges of the road and that gutter pan are absolute magnets for debris, including glass, litter, chunks of asphalt. If it's not debris, then it's snow or stormwater or wet leaves. And the thing to really remember is that what might be a minor inconvenience or a total non-issue for a firmly planted four-wheel vehicle can be a major danger for a bicyclist balancing on two 1-inch tires. And these risks are very much real. There's all kinds of things in the roadway that we cyclists try like hell to avoid. Stormwater grates, pavement seams, even streetcar tracks. That a non-cycling person or city staff might not think twice about, right? And these are real, real risks out there. Here listed as a headline from several years ago about a cyclist who died after his bike wheel got stuck in one of these streetcar rails. And even when a bike facility is clear of debris or other physical impediments and look perfectly fine on a map, sometimes the reality is they're just plain bad. Here we have a trail that too narrow for two bicyclists to pass without one of them coming to a complete stop on the left, and then on the right, an absolute doozy of an unprotected bike lane that's sandwiched between a couple of turn pockets, a couple of travel lanes. And again, this is just travel in one direction. There's a whole nother 3 or 4 lanes on the other side of that median. And here's another one of my favorite examples where the looks can be deceiving. A lovely protected bike lane. Here we can see, looking back down L Street in downtown DC, right? We're gonna flip this, and this is the view, same street, but looking in the other direction down that street. That awesome protected bike lane quickly morphs into a hair-raising transition zone with cars merging across the bike lane from the right to get into that left turn lane. This continues like this for several blocks, and I can tell you from experience that my heart races every single one at every single one of these merge zones. So what can we do to make our bike lanes safer, to overcome these barriers to entry, and to ensure that our growing bike networks can really deliver on their promises? My fellow presenters are hopefully going to offer some creative GIS-based solutions to dealing with many of these issues today. Some of them I think are pretty straightforward. If there's network gap, well, we got to identify and build those facilities. If there's obstructions, we've got to report those. We've got to figure out a way to enforce, people parking in bike lanes. Debris, we've got to make sure that there's robust maintenance and that, there's communication happening at all levels for the agencies that take care of those kinds of things. In Washington, D.C., and in many jurisdictions, we're doing a lot of those things. We've got our 3011. There's a couple of apps that that are in the area working to make it easier to report those kinds of things in bike lanes. We have a pretty robust in a policy regime around accommodations. If a construction project in the top right, you can see the construction project is going to impact a bike lane. We require builders to have a temporary facility. Because it can't be that pedestrians and bicyclists are always inconvenienced by this kind of construction. And then maybe the most exciting thing we have recently is bus lane enforcement. We have quite a few hybrid bus bike lanes that of course are frequently blocked. And we're just starting to see automatic enforcement from buses to help hopefully clear those blockages and ensure that transit times and in their wake bicyclist travel times can be competitive. But of course, there are some issues that are a little tougher to solve, right? What do we do about when a facility feels inadequate or some of these hidden design flaws, right? These are a little bit tougher to solve. And to which I would offer folks like me, the end user, because the success of our network comes down to more than just the builders and the maintainers of our bike facilities, our trails. The end user is a critical part of that triangle, and can and should have a role to play in this situation as well. So with that, I thank you for the opportunity to share a little bit about my experiences, and I am going to turn it now over to folks with some of the tools and hopefully some of the answers. And I think it's going to Craig with Esri. Thank you.
Thank you. Let me share. All right, hopefully you can see me. Good morning and or good day to everybody. My name is Craig McCabe. I'm a GIS engineer on the Living Atlas team at Esri. And today I'm going to be showing a project that was a collaboration between the Living Atlas team and the Story Maps team internally at Esri, with an external input from WABA, who were very generous with their input and subject matter expertise. So I want to give them a shout out. Our goal was to assess the safety and comfort of riding a bike in DC, to access to opportunity and bike lane availability. And I'll talk about what those opportunity locations are in a little bit. The story was conceived and written by Will Hackney, who is in the gallery with us. He's from the Story Maps team, and he will be available for any questions at the end on the kind of story and narrative side. My role was mostly on the kind of data wrangling, network analysis, cartography, and visualization, with a lot of help from my Living Atlas colleagues, as well as assistance from the Story Maps team and Will's colleagues. So I'm going to keep the focus of this presentation on kind of the inputs and outputs of the network analysis and how we kind of went through that methodology. And so let's jump right in to a poll. And because it's a network analysis heavy workflow, I was curious, wanted to get a pulse on how often you're using these types of tools in your work, whether you're modeling transit or transportation in your city or neighborhood. Are you a yearly user? Is it a monthly thing? I myself would put myself in the yearly category, just long enough to forget everything I knew last time I used it. But then once I get on a project, it's, using it daily or weekly for a couple months. So that's kind of where I'm at. While you're getting those poll answers in, there we go. This story is actually two stories. So some people find it either from the narrative story on the left, Opportunity on Two Wheels, or the analysis story on the right, which is what I'm going to be focusing on. But basically, it is a look at how to analyze a methodology, and this isn't the only way to do it. This is one example. Analyzing access to different regions in neighborhoods of DC at kind of the tract and ward level. So how do we characterize different community tracts with access to opportunity? So let's go ahead and take a look at the poll results. I think I've closed it, so I'm going to have to check. Oh, there it is. It's out. Thank you for everybody who submitted the results quickly. So we have a lot of never, and that was me not too long ago. Some daily, weekly, so good spread, nice little distribution there. Hopefully you'll find some little nuggets of useful information and workflow possibilities that you can take home and use yourself. So as we all know, and as our previous presenter spelled out, bicycles are an egalitarian means of transportation and access to opportunity. And in the context of this story, opportunity means your school, your job, a grocery store, hospital, places that you go. And this could be kind of places you go daily, which might be your school or job, maybe weekly for the grocery store, monthly or quarterly for a hospital. Kind of you get the idea there. And so, it can be a little bit scary riding a bike around a city, a densely populated area, as we've seen. And so what are ways that we can reduce the stress and risk? Bike lanes are number one. And DC has been great in kind of at the forefront of supporting the biking community with their addition of new bike lanes over the last couple of decades or so. So over 100 miles, which is pretty impressive. So how can we create a metric to rank access to opportunity in different neighborhoods around the district? And so this little graphic on the right kind of summarizes what we're trying to do for every community. This is a Ward 7 tract on the bottom right there. And this is the route to the nearest hospital. And it kind of breaks down along that route what kind of bike paths or off-street trails or roads you're going to traverse. And so we can use that kind of breakdown to rank the score of that neighborhood based on access to that opportunity location. So why DC? Number one, our author, Will Hackney, is a resident of DC. And so it's always good to have a subject matter expert who can kind of ground truth the data. WABA were also really great as subject matter experts just all around in kind of reviewing our story as we were writing it and building it. So we want to thank them for that. But as any GIS analyst or user of GIS data knows, data is everything, and it's 90% of the problem. Getting good data, cleaning it up, getting it ready to analyze and visualize. And so one of the real benefits in this project is Open Data DC. It was almost our single point source of data for the project. And we had probably 95% of the data came from Open Data DC. There were a couple of layers like our census and demographics, which came from the Living Atlas. And I think Will and I both did some manual creation of data for things like grocery stores, which we were having a hard time finding authoritative sources in Open Data DC. But other than that, even the network data set layers, the streets and lanes all came from DC. So we could talk about the building of the network data set. This roadway subblock was kind of the foundation of that. And it was really nice because they have attributes for these different bike lane types, the conventional, protected, and buffered. We simplified it into 3 kind of merging single and dual bike lanes, just to kind of simplify the analysis, but you could go with a more nuanced analysis if you wanted to get more detailed. But that wasn't all of the network. So we had to plug in some additional trails, which are used in the mall and in Rock Creek Park, to kind of fill in some gaps in mobility. Unfortunately, that entailed a lot of manual editing of the data. So we have the original Rock Creek Park trails, for example, here. Will took a look at it and said, no, very small percentage of these are actually useful for commuting. You don't want to go single tracking, or maybe you do on a mountain bike to get to work or to school. And so we ended up trimming it down. And then the additional work came into plugging this into the other network layer, the subblock roads. And so that's kind of where a lot of the manual editing and consolidation came in, was in the kind of network side of things before we built that network data set. So this is the end of all of those layers kind of coming together. Here we can see the representation of the bike lane types you saw in some pictures from the Wabbit demo. And we kind of are moving on the left-hand side from less comfortable to more comfortable. It's great if there's a lane period, but if you have a protected lane, that's even better with some kind of curbing or planter boxes or whatever to kind of keep that additional buffer from the traffic. On the right-hand side, we have our 8 wards of DC. Again, you can get a visual overview and you kind of get a sense of the density of bike lanes throughout the district, with most of them in wards 2, 6, and 1, kind of the business districts and downtown areas, less so as you get out from the core. So for any network analysis, we need kind of an origin point and a destination point. Our destination point are our opportunity zones. Our origins are our census tracts. These are coming from Living Atlas. And along with them comes some demographic information we to enrich and understand better the residents of that neighborhood. So to do a point-to-point, we need to get a centroid from those tracts. And in network speak or parlance, that's an incident point. And now we need our destination points, our opportunity factors, and these come in 6 buckets, a total of 17 different places you need to get to. Some of them kind of on daily frequency, from education to health, or transit. Some of them less, maybe weekly for worship. Courthouse, maybe that's yearly or monthly. And so these are all the different, spider webs of routes that we want to create from every tract centroid. So the data set essentially looks like this. Before we're ready to do network analysis, we have our network created. We have our origin, destination, or incident and facility points. And now we can go in and actually run the analysis. So we might as well just do it live here. And you can actually download a map package. It's called, I think, sample data, but it's all the data that was used in this story map. And so you can kind of recreate using that kind of detailed story, the analysis that we did for this, and apply it to your city, kind of using the same types of workflow and methodology. So here we can see our different opportunity points. Let's go ahead and set up a new analysis layer. And we're going to do a closest facility analysis. So create a new layer there. And the first thing we want to do is load up our incidents. So to simplify things a little bit, let's just show let's do grocery stores. So access type, and then we have grocery store, apply that. And now we can see a subset of the grocery stores, the Harris Teeters, the Safeways in the district, to do our analysis. So back here, we're going to import facilities. And again, these are our grocery stores, our destination access points, opportunity points. And we'll hit OK to load those up. Now we'll import facilities. These are our origins. So the centroids of our tracts, and those origin tract points will use the GeoID, which is the FIPS code, to differentiate those in the output. And the next thing we want to do, and this is a kind of one of the custom features of this network data set, is that I've added these costs. So as any route is created and traversed, it's adding up the amount or the distance of each type of protected or unprotected lane. So if it's going across a conventional or protected lane, it's adding up the number of meters along that route. In addition to that, it is preferring by level of safety from off-street trails all the way down to conventional lanes. Basically, it has kind of a hierarchy of preference so that you're without going too far out of your way, you're going to prefer a bike lane when it's available. And so with those accumulators on, we can now run the analysis. And it just takes a few seconds, as you can see. And what we get are these routes. We open the attribute table. And each of these accumulators now show the amount of distance along each of our bike path types. And so we just essentially repeat this analysis for all 17 POI types, and that gets us to kind of the analysis that we can then summarize at the track level. So here's a fun animation of two different tracks, one over here, kind of downtown commercial district, and one over in tract 111. And we'll just do an animation and show you kind of the spread of those spider webs to get to those opportunity locations. Each one of these is labeled and colored according to the legend here on the left. And so I think the one kind of outlier opportunity location was the Sikh temple in the Northwest. There's only one in the open data data set for worship locations. And so that was always the furthest that people were traveling, was to get to that, one temple up in the Northwest. But you can see just the spread of those routes between this gray example here in the left-hand side and tract 111, and it's really quite varied depending on, number one, the size and location of the tract. And so putting it all together, we have this networked access model where we take all of those routes and we score them according to kind of the importance or prominence of, the daily, these are kind of more daily destinations on the top, going to more weekly and less frequent. And then we heavily weight the value of better lane availability along that route. We divide it by total ride time to kind of normalize that by length, and then we combine all of those with all the weightings into a single score that's kind of, it's not really a value that means anything other than it's kind of a relative ranking of access to opportunity in the district. So because it's a lot of data, a dashboard is often the best way to kind of understand and navigate and visualize. And so at the end of this story, you can scroll down and we go into a lot more detail than I'm covering here. But there is a dashboard, and I'll just open up a tab here. And we can interact with it. We can click on a tract. So this is the 12th ranked out of 206. We can get our median income and population kind of demographics. We can filter. So if we look here, we can see our health scores. We can filter by ward. So let's go to Ward 2, which we were just looking at. We have a very high access to opportunity score for health. So let's see what that looks like by turning on some of those health points. So here's our health locations. If we just wanted to look at, for example, grocery stores, which we saw before, we can just turn off our access score map and see, each one of these routes from the tract centroid to the nearest grocery store. Click on that route, get information about traversing different bike lane types. In this case, we're going from this tract over to a grocery store. Let's see, what is it? it's like streets market, and we have a good amount of buffered bike lane and the rest covered in slow service roads. And so a nice way to kind of get through, and we can look at ride times. We want to turn on all of our wards. We'll select all there. We'll select, let's see, all of these. And then we can get relative ride times or average ride times for all of our kind of health-related locations for all of our wards. And so this is kind of the inverse of the other score map, in that lower ride times is better, longer ride times worse. So a nice way to navigate, very simple example of a dashboard there. But a good way to navigate dense data sets where you have all this information and you need to be able to kind of flip through it in an easy way. So that's in a crux, the analysis we did. We wanted to summarize and make some assessments on relative access to opportunity. There were some lessons learned if we did it again. Number one, we have this arbitrary boundary in DC. I'm sure there are grocery stores just outside the boundary that are going to be closer than something further inside the district. And so these weren't accounted for. It creates some additional challenges in getting other data sets outside of the open data portal for DC. But if I were to do it again, I would probably buffer that DC boundary by a certain amount to include those edge opportunity locations. Next, tracked centroids. We use the geometric interior centroid of the tract. And if I were to do it again, I would use a population weighted centroid, which better represents concentrations of people where that centroid might fall in the middle of a park and not in kind of a densely populated community. And so going a step further, it would be interesting to do the same analysis at the house level, essentially getting a very detailed look at opportunity and change in opportunity almost continuously across the city. Another improvement based on another project that came up a year ago was using the Street Map Premium custom roads. So in my case, I created from scratch a network data set and built the restrictions in that I needed, the accumulators by path. Street Map Premium allows you to, using the custom roads product, to clip out an AOI. And it includes all the traffic controls. It includes tons of restrictions, dozens of different ways you can kind of fine tune the network. It doesn't have a biking travel mode, but you can adapt walking. There's lots of kind of overlap in biking and walking routes or modes, increase the travel speed and adjust some of the restrictions for where you can bike. But we ended up doing this with this example. It was a park access story and project that some interns from last summer at Esri took on. And so a nice thing about Street Map Premium is you have directions. So we have that extra level of information as far as getting from point A to point B, getting to that opportunity location. Another thing that I included in this kind of revisiting the access to parks was incorporating slopes. Slopes can be a real barrier for traveling by bike, as anyone knows who's lived in San Francisco. And so how can we incorporate that as a cost? And so what I did was I kind of chopped up all of the streets and trails at like 5 or 10 meters, calculated the slope percent along each one of those pathways, and then did the same kind of accumulation along that route. So you actually get a score about how hilly you can restrict above a certain amount of percent slope, 8 or 10%, which may be too much to go up. Going down is no problem, of course. And so that was another way that I would probably extend this if I were to do it again for DC, because slope can be very relevant, especially in the Rock Creek Park areas, you can see with lots of hills. So I want to thank a lot of our collaborators here. On the Story Maps team, Will was the author of the story. Gustavo created some incredible illustrations. Other members, Hannah, Cooper, and Liz, with support. On the Living Atlas team, thank Emily Miriam for her help with cartography, Michael Dangerman for just kind of the concept and the model that we use to analyze, and Melinda Morang, on the network analyst team. She's always my go-to every time I forget what I knew a year ago, and she reminds me of which button I need to press. So lots of thanks to her. And then, of course, thanks to the Washington Area Bicyclist Association. Colin Brown and Jonathan Stafford were really great in working with us for this story. And so that's what I have. I hope you found it interesting. And now I'm going to slink away back to where I came from and see you at the Q&A session.
Hey everyone. Hello and welcome. My name is Samantha Kriegsman, and I'm a Senior Partner Account Executive at Samsara, supporting public sector partnerships. Today, we'll discuss how Samsara integrates with GIS solutions to innovate urban mobility in the public sector and enhance bike lane safety. But before we get started, I'd love to poll the audience here. So I'm curious to learn if your team has ever had concerns regarding city vehicles being involved in bike or pedestrian accidents. So please go ahead and check out the poll below and submit your answers. And while you take a moment to answer, I'll provide a little bit of background on Samsara. We're dedicated to empowering public sector organizations to operate smarter. Our Connected Operations Cloud helps organizations innovate how they deliver services to provide to their constituents with the highest level of support. By integrating GIS, we offer a comprehensive view of vehicles and equipment, assets in general, especially those pieces of equipment that improve urban mobility, like street sweepers or snowplows. Samsara is a mission-driven organization, and we're passionate about how we partner with our 20,000 customers globally and over 1,000 public sector agencies to help them improve their operations. Simply put, our mission is to improve the safety, efficiency, and sustainability of the operations that power our global economy. And we partner with our customers to solve complex problems in their operations with intuitive technology. As much as we can talk about our dedication and mission, what truly matters is the real-life impact we're having across the nation that improves urban mobility and helps enhance bike lane safety. As we know, one of the keys to improving urban mobility is to create safer streets and roads for everyone. Vehicle traffic being safer results in better safety for cyclists, pedestrians, and others who use the roadway. Our safety solution focuses on increasing safety, which has been compounding positive effects on bike lane safety. So let's take a look at some customer stories to see how Samsara solutions are making a difference in some of the largest counties and cities. But before we do so, let's check out the poll results. All right, so it looks like we have a pretty solid mix here. Some people haven't experienced this yet, but there are quite a few organizations who have been fortunate enough not to have incidents, but this is something that's on their radar. And then a smaller portion who have experienced incidents so far. So we'll be able to show here in a few slides how Samsara can help be proactive in making sure that these incidents don't happen within your city fleets. I want to emphasize a crucial point. Industry leaders in the public sector trust us with their most complex operational challenges. From the City of Boston to the Tennessee Department of Transportation, leading public sector organizations across various regions rely on us to tackle their toughest issues. This trust is a testament to our innovative solutions and unwavering commitment to excellence. We believe in true partnership, working closely with our customers to understand their unique challenges and goals. By engaging deeply at every step, we ensure long-term success through collaboration and support. Customer feedback is vital to us, driving our innovation and helping us continuously refine our offerings to meet evolving needs. This cycle of feedback and improvement keeps us at the forefront of our industry. The logos on this slide represent not just customers, but partners who have achieved significant improvements with our support, from modernizing transportation systems to optimizing waste management. So when we were founded about 9 years ago, our core products focused on vehicle telematics and camera-based safety. But since then, we've expanded our functionality to more areas that are important to our customers. We're bringing together data from across physical operations into a single integrated cloud platform that includes mobile apps and driver workflows, APIs and integrations, and more. But it's not enough to just connect physical operations and gather data. You need to be able to see the right data clearly and harness it in order to achieve mission-critical outcomes. So next, I'd like to focus specifically on our safety component of our solution. Couple of customer examples here. First example comes from the city of Allentown, Pennsylvania. By implementing our solutions, they were able to significantly improve their safety review efficiency. With the help of our advanced video retrieval capabilities, Allentown saved over $1 million in taxpayer dollars. Additionally, they managed to reduce approximately 10 hours of work per week, allowing their team to focus on more critical tasks. We also have the city of Denver. So Samsara is helping them make their roads safer. Denver utilized our platform to promote safe driving behaviors among their fleet. The results have been outstanding. A 99% decrease in harsh driving incidents, a 98% reduction in distracted driving, and an overall 94% drop in safety incidents. These impressive statistics highlight how our real-time data and actionable insights can create a safer environment for both drivers and the community. Another example that I'll mention, they aren't shown on here, but the city of Boynton Beach in Florida. The city implemented AI dash cams and experienced an overall decrease in measurable risk factors by 58% compared to cities of their similar size. Some of those risk factors included distracted driving, policy violations, speeding, and harsh braking. This, of course, leads to safer roads for constituents. The city credits Samsara's coaching platform as one of the main reasons for reduced incidents. Knowing the exact categories that need improvement for drivers allow for targeted intervention by coaches. In addition, the city has also been able to exonerate drivers by utilizing our cameras. Fighting false claims can be costly for any organization, so the ability to instantly capture footage of harsh events for law enforcement and insurance captives provides a significant ROI. Finally, we'll look at Athens-Clarke County, where our solutions are boosting energy efficiency. By optimizing routing and incorporating driver gamification, Athens-Clarke County achieved a 58% increase in fuel efficiency. Additionally, they saw a 15% improvement in driver safety. This case underscores the power of data-driven decision-making and how it can lead to both environmental benefits and enhanced safety measures. So just a quick recap on how the dash cams operate. They are plug-and-play devices that can easily be installed in any city vehicle in about 15 minutes. Data is captured and sent to the cloud, where people in the back office, so fleet managers, safety managers, operations managers, can instantly get footage of harsh events, either on their phone or on the Samsara dashboard, and they can save those incidents for later coaching or to provide to any sort of relevant law enforcement. So the cameras are both proactive and reactive. So we've seen how our technology is making a tangible difference in cities like Allentown, Denver, Boynton Beach, and Athens-Clarke County. So let's dive into the specifics of one of our key technological innovations that underpin these successes. And we'll go ahead and talk about 3D GIS technology. This innovative solution offers unprecedented opportunities for real-time monitoring and safety improvements in urban bike lane management. With 3D GIS, cities can visualize traffic data in real time, allowing for immediate action to address safety concerns and optimize bike lane usage. It's truly a game changer for urban mobility. Leveraging this kind of technology significantly reduces accidents and enhances the efficiency of bike lanes. By integrating real-time GPS tracking and dash cams, cities can proactively manage bike lane safety, ensuring a smoother and safer experience for cyclists. For example, in Denver, we've seen a 99% decrease in harsh driving and a 98% drop in distracted driving, which are critical factors in reducing accidents and improving overall safety. Data-driven decision-making is at the core of what we do. Samsara's technology enables local governments to make informed decisions based on comprehensive data analysis. This leads to smarter urban planning and more efficient resource allocation in Sacramento. Our solutions have contributed to a substantial reduction in greenhouse gas emissions, supporting their target of a 65% reduction by 2030. Finally, our solutions are scalable and customizable to fit the unique needs of different urban environments. Whether it's a bustling city center or a suburban neighborhood, Samsara's technology can adapt to various challenges and requirements, providing a versatile approach to improving bike lane safety and efficiency. Our integration with Esri allows for advanced spatial analysis, enhancing our capabilities in urban management. This synergy ensures you have the detailed geographic insights needed for smarter data-driven decisions, ultimately improving road safety and urban planning efficiency. So some key takeaways here: enhancing safety and efficiency. Our solutions are making cities safer and more efficient by leveraging technologies like AI dash cams and real-time GPS tracking. We help cities significantly reduce driving incidents. You'll recall Denver achieved a 99% decrease, 98% drop in distracted driving. And this proactive approach also streamlines operations, reducing downtime and ensuring vehicles and infrastructure are always in top condition, contributing to a 94% reduction in overall safety incidents. Takeaway number 2, data-driven decision-making. It's at the heart of what we do. So our platform provides local governments with comprehensive data insights, enabling smarter urban planning and real-time monitoring of infrastructure. This approach not only addresses immediate concerns, but also supports long-term strategic goals. And lastly, building scalable and customizable solutions. We want to make sure that it can fit the unique needs of various urban environments, whether managing a city center or suburban area. We're providing versatile applications that have proven success across multiple sectors. From Allentown saving over $1 million to Denver's comprehensive fleet management, our technology adapts and excels in diverse settings. So thank you for joining us today and participating in the webinar. I hope that you found these insights valuable. If you have any questions or need further information, don't hesitate to reach out afterwards. I'll be here. So thank you again for your time, and I look forward to continuing the conversation. Have a great day, and I'll hand the floor over to Bill.
Thank you, Samantha. Can everybody see my screen?
Looks good. Got it good.
Perfect. Thank you so much. Looking forward to having the opportunity to speak to everyone today in today's webinar. Really what I want to get out of today is to give you guys a little bit more information on the latest in using machine learning to extract highly precise transportation information at scale across the country, but also give you a little bit more information on some of the unique programs and partnerships that are allowing for a really cost-effective approach in order to extract some of the important asset information that's required in order to do some of this long-term planning and to apply for some of the many federal grants that are available out there. I think Craig summed it up best that data is everything. I would go one step further that very accurate, up-to-date data is everything. I can't tell you the number of MPOs, county level governments, state DOTs, even the federal government, where we've had the opportunity to work with. And either A, they haven't had the opportunity to go through and extract some of their active transportation features, like all of their bike lane connectivity and sidewalks, or they have aerial programs that need to fly out, and then it takes large teams months to digitize the data. And before they're even able to start doing some of the more interesting spatial analysis, some of the data can be up to a year old. And so really that's where we want to live as an organization. We've been spending the last 10 years to extract highly precise transportation map geometry from the latest aerial, oblique, and street view imagery across the US. What I want to stress is that we are a content provider. We provide vectorized data from the latest aerial imagery that can work in any of your applications that you're used to today. Many of our government clients use Esri applications, and so we don't want to change anything that you're used to using today. We just want to be that layer that helps you identify the assets that are most important to you so that your teams can get to work faster and to start to get to work with the spatial analysis. So our vision and who we are as Ecopia, we want to digitize the physical world. But what does that really mean to everybody on today's phone call? We want to make your lives a lot easier. We want to try to completely eliminate manual digitization so that your teams can focus on the more interesting work, whether that be visualization, statistical analysis, or any other kind of geospatial analysis. When we initially got our start, our organization was focused working with federal governments using satellite imagery to identify basic features like footprints and roadways. But what we recognized was if we were to use higher resolution aerial imagery with the same platform that we've created, we can extract a much broader portfolio of information and information-based layers that can be useful for all three levels of government. And that's really where we've focused our time now today, to identify everything in the transportation right away, whether that's bicycle lanes, sidewalks, or anything that can help with active transportation projects. I like to quickly show what this potentially looks like. This was a project that we worked on with the Baltimore Regional Transportation Authority. There's about 60 transportation features that our team can extract across the entire US. But this particular example shows what the team was working with before we had the opportunity to work with them. So this is identifying all of the pathway information. I'll show you several examples of the same data set for bicycle information as well. This was the open data that their team was using that was created from hundreds of different sources and thousands of different contributors, versus what we were able to assist with when we had the opportunity to work with the latest aerial data and extract all of that same information. So having geometry that's snapped together appropriately and creating 10 times the amount of data so that they can have a much more holistic look at of where their assets are across the entire community. And for bike lanes and sidewalks, we can actually also go one step further and add width measurements to each one of these individual polygonal segments. And so this is a project that we are undertaking across every city across the US, and we're going to keep it up to date every year using the latest aerial imagery. And so right here, you can, even before running a statistical analysis, you can see where there might be problem areas. In this particular example, everything in green, it represents a pathway that's 6 foot in width and wider. Anything in yellow and orange is 4 to 6 feet, and anything in red is below 4 feet, which doesn't even meet some of the more recent, which doesn't even meet some of the previous ADA guidelines. So you can really quickly put together some of the planning information that's required to apply for programs like Safe Streets for All and some of the other ones mentioned earlier in the introduction. And so these are the kind of map features that our team is extracting, what it's allowing people to do is to get started with a lot of their Vision Zero planning, a lot of their Safe Streets for All planning. And so similar to what what Craig had mentioned and some of the other applications that are available, you can start to layer on incident data and have a much more granular look at why there might be incidents in certain locations and certain intersections. All of this data can be merged into a single linear referencing system if that's something that your team prefers. But really what we want to be able to do is to capture much more detail so that you have a much more granular look at what the transportation infrastructure looks like across your entire city. So I think it's most important to jump into some of the examples at the end, but I will quickly touch on the state of machine learning. Anybody who's saying that they are just using automation and throwing automation at remote sensing data, whether that's satellite, aerial, or street view, that should be an immediate red flag. Even we've been doing this for 10 years, and we always want to triple check our results so that we can ensure that we have greater than 95% accuracy with all of the map features that we are creating for our clients. Selfishly, we actually want to do that to improve our training sample for future projects so that when we are identifying new features over a new terrain, we have improved results and it reduces the amount of work on our QA/QC. One of the benefits of the system is that we are image agnostic. So we're happy to work with imagery that your teams have already invested in. But we also have partnerships with all of the major aerial providers, which allow us to have unlimited access to both rural and urban imagery, which is allowing us to support the program that we have created so that we can help identify these features and make sure that they're available not just to the commercial sector, but to all of our public sector clients as well. And really, that's where we want to get to, is we want to try to take advantage of the best of both worlds. So manual digitization has human level accuracy. We like to say that's about greater than 95% accuracy, but it really has a lot of difficulty managing to keep up with the amount of new imagery that's available. And it can also be quite expensive and slow in order to keep all of this asset information up to date. Whereas what we're trying to do is take the best of both worlds. So we want to be able to create large-scale transportation asset information so that your teams can use this to apply for federal funding and to mix it with some of the other data sets that have been discussed by some of the other presenters here today, so that you can have a much more granular understanding of what might be the cause, whether it's having 6-lane roadways or whether it's having sheltered medians for pedestrians, whatever that might be, or actually having different kinds of class 1, class 2, class 3 bike lanes that might be more protected for its citizens. And so that's really what our objective is we want to have large scale, accurate, and up-to-date map data so that your teams can get right to work with your Esri applications and have a much better experience keeping track of what's going on in your communities. I'm going to quickly I'm going to show you a more dynamic demo in just a minute here, but this is just an example of an award-winning data set that we created with Fair and Pierce across the county of San Bernardino, the largest county across the United States. And we were able to speed up the mapping process by 45 times by using our traditional methods. Now, we've previously worked on a project-by-project basis in the past, and at the end of today, because of some of the work that we're doing with NOAA, we've had the opportunity to work with NOAA's Coastal Change Management Program. We are already mapping all of the United States every year. And so that's one of the key takeaways that I wanted to let everybody know, is that we will have bike lane, crosswalks, and sidewalk information for all major urban centers available for your use for whenever you may require, just because of some of the other initiatives that our team is having the opportunity to work with. So I just want to be cognizant of time. What I would like to do is just quickly show what this potentially looks like. If your teams can still see my screen right here. So this was a part of the San Bernardino example. And so what you can see here, we can highlight specific features, and all of this is just our viewer, but all of this vectorized data is easily moved into Esri applications and has their own attribution data, whether that's width measurements, whether that's when the data was extracted, what imagery the data was extracted from, and we can keep this up to date on a consistent basis. And so you can look at things like shoulders. I know in some communities, shoulders end up becoming some of the bike lanes. Then you can be looking at some of the other pieces, whether that is the marked bike lanes, which can be found in purple here. And then also we can be looking at unmarked bike lanes as well. So really just trying to help your organizations get an understanding of where all this information is to get started. I know sidewalks are also a big one when we're talking about active transportation features. So you can see sort of everything start to layer on top of each other. So you have a much better look at what's going on across the entire region. So I'll take a pause there. There's several examples I can show, but I know we are a little bit over time right now, and definitely want to get to all of your questions. But really just wanted to make sure that everyone's aware of data that's available. Too often we see people trying to recreate the wheel, where people are creating very similar data sets in insurance, civil engineering, and even within the government. We have some municipalities who are building data sets, and then the DOT are building their own separate data set. And so that's where we've really been helpful working with and we've also worked at the state level supporting organizations like the Illinois DOT and Texas DOT in order to collect some of this information so that to make your lives a little bit easier. But I'll pause there, and I want to thank you, everybody, for your time today. And also invite all of my previous presenters back to the stage to answer any questions that might come up from the audience. So just opening up the Q&A. I think, Craig, the first question's for you. Where did your data on opportunity points come from? And are there any equivalent sources of data sets in other locations nationwide? I found that it's easily available zoning polygons aren't specific enough to be useful.
Yeah, so all of our opportunity locations came from the open data portal, the DC Open Data Portal. There are other sources you could use, OpenStreetMap or Business Analyst, ArcGIS. I've used to kind of fill in gaps in data where I've had it in other projects. We didn't use it here because, with the exception of things like grocery stores, which would be a great use case for Business Analyst or OpenStreetMap, everything we needed pretty much we could find in the Open Data Portal for DC, which is why it was such a great town to do the study on.
Perfect. And so, Craig, this also might be, are the Esri story maps and other visualization tools created for this webinar available for us to interact with ourselves?
Yes, absolutely. You can take a look at the dashboard. You can take a look at some of the animations. I showed one of them, and they're all in the resources. There's a link to that first narrative story, as well as the technical kind of methodology story, which is more what I touched on here. So anything that you saw, you can either download and repeat, like the Pro project you can download. There's a link in that narrative story to that data set, and also a link to the technical story. So yeah, it's all out there. And if you just click on the resource links on the sidebar there, you can get it from there.
Perfect. Yeah, Craig, and I want to echo the resource links. I know several of our presenters have put several pieces up there. We've included some of the areas it's sort of a help me link for some of the federal programs. I do know that we've worked with some of the municipalities. It can be a daunting task. I mean, I've seen some of the larger cities have dedicated personnel that are going for some of these programs. So there is some help me links there, and we're always available. I'm sure many people on this call are always available if they want to answer any questions on sort of how to get started and sort of how to make a successful application there, because there's a significant amount of funding for a number of different use cases, whether that's the decarbon program or the Safe Streets for All, as I mentioned a little bit earlier. The next question was from Clarissa, directed to the Ecopia team. So what about rural areas? So that's a great question. Our team is working with the latest aerial imagery in order to extract all of the data across the country. We typically work with Nearmap just because they have the urban centers covered every year. So we will have all urban centers. It's about 1 million square kilometers. So a significant portion of the country. I think it includes over 90% of the population that's covered by Nearmap data. So we will always keep those up to date with that refresh rate. What we do in the rural areas, and we need to cover the rural areas, especially for our NOAA Coastal Change Management initiative, is we work with organizations like Hexagon who extract data for the NAPE program. So typically with Nearmap, we're working with 3-inch resolution in urban centers. And then the rural areas are typically captured on a 2 to 3 year cycle with 6-inch data. So we typically follow the imagery capture routes just because that is our raw data inputs. So we will have the entire country covered. We're just finishing it up right now, but rural areas tend to be maybe 2 to 3 years older at the most. We have another question from Clarissa. I know that there are a lot of tools that are available in order to try to help with the automation process. Really, I would love to have a conversation with you, Clarissa, just because we have a data set that is pretty much done for the state, and we can help you at least get started. And then that might be something that that you can sort of take a look at, and to help support the effort that you're already working on, because we do have many of the urban centers already covered, and we're looking to finish up some of the more rural areas as we get into the end of September. So we'll give everyone just another couple seconds here. I didn't know if any of our presenters had any other questions from in between each other. We'll just give each other another maybe 30, 40 seconds, see if any other questions come through. Well, if not, we're always available as a group of individuals. We will make sure that all of our contact information and the recording, as mentioned, with all of their slide decks, will be made available to everybody who is on today's call. Please feel free to share that information. And looking forward to answering any questions that your teams might have in the future. But otherwise, I want to thank all of our presenters who are here today. I want to thank ConnectMii. And the sponsors that were here today, and everybody who took the time to learn a little bit more about this subject. All of us are really excited about what's going on in this space. I think that there's been a tremendous shift to focusing on making our communities more equitable for all modes of transportation. But there's still a long way to go, as you heard from Kevin and some of the other individuals there. But I think people are talking with the funding. The U.S. government is really is putting their money where their mouth is, and making a lot of grant money available in order to address some of these pieces. And I would also suggest people take a look at the Safe Streets for All program, because it has not just an implementation piece to it, but also a planning aspect to it. And it's very easy to qualify for the planning funding. So you really just need to collect some basic information for your initial application, so that you can have an idea of where some of your investments might be going. So it's a useful exercise. It's a lot easier to get involved with versus having something that is more focused on sort of the implementation and construction piece. And so there's some great information sources online on how to get started, but it's a very easy entrance into qualifying for some dollars to help with these initiatives. Otherwise, I want to thank everybody very much, and I hope everyone has a great day.
Thank you.